Okay, so I thought I'd go through all the example problems today in sections 1 and 2 so that we can have an idea of whether or not we're doing the work correctly and how I expect it to look. So, starting with example 14.1, what are the hydronium ion concentration and the hydroxide ion concentration in pure water? When we have pure water and it disassociates into hydrogen ions or hydronium and hydroxide ion concentrations, one of these gives me one of those and one of those. So if I lose X here, I would gain 1X here and 1X here. So the concentration of hydrogen or hydronium ions is equal to the concentration of hydroxide ion concentrations. And so if I make them both X, then I can say that X times X is going to equal kW for water, which is 1.0 times 10 to the negative 14th. So that means that X squared is equal to 1.0 times 10 to the negative 14th. So X would equal the square root of 1.0 times 10 to the negative 14th. And when you put that into your calculator, you would start by putting in the square root sign. So, and that's above the squared sign right up there. So I'm going to hit the blue button, square root 1.0 second EE. Again, remember you can't use times 10. You have to use the EE. I'm going to put negative 14, and that equals 1.0. Oh, sorry, I had something already in there. So second square root 1.0 second EE negative 14. And that equals 1 times 10 to the negative 7th. You'll notice that it does not take care of significant figures for you, so you have to go back and put those in. So it'd be 1.0 times 10 to the negative 7th equals, and that would be molarity, is going to equal the concentration of hydronium ions, and it's going to equal the concentration of hydroxide ions. Okay, I'm going to go on to the next question, then I'll probably break and do the next two. So, 14. Inverse proportionality of hydronium and hydroxide. A solution of carbon dioxide and water has a hydronium ion concentration of. So my hydrogen ion concentration is equal to 2.0 times 10 to the negative 6 molar. What is the concentration of hydroxide ions? So now I want to know, what is the concentration of hydroxide ions? So I'm going to let that equal X. So hydrogen ion concentration times hydroxide ion concentration equals 1.0 times 10 to the negative 14th anytime it's at 25 Celsius. All these problems should be at 25 Celsius. And so hydroxide ion concentration is going to equal 1.0 times 10 to the negative 14th divided by 2.0 times 10 to the negative 6th. So, to put that into my calculator, I'm going to have 1.0 second EE negative 14 divided by 2.0 second EE negative 6 equals 5.0 times 10 to the negative 9th molar. Okay, so I hope this helps. Please stay tuned because I will have the next two on another video. Thanks.